Hello, so this is going to be another series of video labs that I'm going to do the labs and you're going to take some data. Okay, so we're going to be making biodiesel. Biodiesel is a type of fuel that is meant to replace petroleum-based fuels, but it's made from biomass. So, and it's converted to fuel. So there's two types of biofuels. There is the ethanol, which is made from fermentation of carbohydrates. And then biodiesels are made from lipids, from oils. So today we're gonna be taking olive oil and vegetable oil and corn oil. Right, you're gonna just be assigned to one of them, but we're gonna be converting these into biodiesel, and it's actually a very simple process. And biodiesels are used in trucks and cars and vehicles and things like that, just like diesel engine. Okay, so I'm going to start with olive oil. Okay, and the instruction says that I need 4 of these. So if you were doing this in class, each group will get an oil, and there's 4 people per group, so each person gets a vial. So into these vials, I'm putting 10 milliliters of the oil sample, so that's going to be right up to here. So I'm going to do that 4 times. So I got 10 mils of olive oil here for vial number 1. Okay, here. Now, biodiesel can be made from any kind of vegetable oil. I think you can even use like animal oil. It doesn't have to be vegetable oil as long as it's a fat. And it doesn't have to be fresh oil. It can be used oil. So what they can do is they can collect leftover oils from restaurants and things that make deep fried foods. And then use them to make biodiesel. So that can't be the main source because that's not going to be enough, but it's a good way to recycle some of the these oils that will otherwise be thrown away. Okay, so I have 10 milliliters of olive oil here, and then the next is going to be I'm going to be putting 2 milliliters of red, which the only why it's red is because I added food color so that there will be a color difference. Sodium hydroxide, which is the powder that I put in, which is dissolved now in methanol, which is a type of alcohol. Okay, so it's a sodium hydroxide methanol mixture. Then I'm going to be putting 2 milliliters of each into these. Okay, so I have another one of these. Actually, I can just measure it out exactly here because these are graduated, then I don't have to get this dirty. Because oils are a little pain to clean. So I have exactly 2 mils here. Maybe I should make this a little darker. Okay, 2 milliliters of the methanol and sodium hydroxide. Okay, so what I want you to do initially is I want you to take a look at what it looks like right now, right? So I added the sodium hydroxide. Now there's a glare, isn't there? So you see what that looks like right now? So, so the methanol hydroxide, sodium hydroxide is floating on top, and the oil is yellow on the bottom. Okay, so I'm gonna cap it up and do a quick shake. is 2 shakes, right? After 2 shakes, what is it gonna look like? This is very bad that I have a glare here. Let me stand right here so you can see it better, okay? So I'm gonna do 1, 2, here goes. 1, 2, 1, 2, 1, 2. There we go. See that? Maybe a little closer, a little further. Let's see, right? So I want you to make a note of that. Okay. So that's after 2 shakes. Now I'm gonna do 7.5 minutes of shaking. Oh great, so now I'm gonna have to shake, 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 and come back in 7.5 minutes. All right. So I need to time myself, don't I? Okay, so I'm gonna start the timer and start shaking, okay? Seriously, this is worse than those shaking the rocks. Okay, that's 7 minutes. I'm gonna have to do this again. Stop. Okay. All right. So after 7 minutes, you're supposed to take a look at what it looks like. Now, this glare is too much. Maybe that time of the day to be doing it. Okay, so I shook it for 7.5 minutes. Let me stand in the way for the sun so you can see. Let's see, where's my piece of paper go? No. Here you go. All right, I want you to observe and see what it and make observation of what it looks like. It's kind of, now maybe it's better to see it from this side. Can you see that? Maybe I'll move over to the other side and we'll do it from the other side. Okay, yeah, so that's what it looks like right now. Right, kind of this peachy color, uniform, right? So recall what it looked like before. Before the red was on top. Right, now everything is nice and even. All right, so I'm gonna now shake it for another 7.5 minutes. Okay, so this is really sucky. All right, so I've been shaking for another 7.5 minutes, and this is what it looks like. So now it's been shaking for a total of 15 minutes. Remember, this is olive oil. Okay. So well, the sun is in my face this way. I didn't find this very well, huh? I guess I didn't really need to. I'm doing it right now. I'm doing it in the fume hood, which in hindsight, I'm realizing I probably didn't really need to do that because there's not too many fumes coming out. But later on, I do. So I don't know what's the best way to show you this, but you can see the colors. Yeah, I don't know if you're supposed to see that much of a difference between the last time we did, after 7.5 minutes, right? But you can see that it's fairly uniform, kind of orangish color, right? Now what I'm gonna do is I'm gonna let that sit for another 15 minutes, but now without shaking. We're gonna let this settle, okay? And then we're gonna take a look at what it looks like. So remember, we started out with oil and methanol. And do you remember what was on the top and what was on the bottom? It was the orange that was on top, which is the methanol, right? And the oil was on the bottom. So what does that tell you, the fact that the methanol was sitting on top? It tells you that it's less dense, right? So that means methanol is less dense than the oil, which was sitting on the bottom, right? Now think about what you know about oil, right? And when you mix oil and water, what happens? Well, they don't like to mix because they have different properties. Oil is polar and oil is non-polar and water is polar. And polar and non-polar substances do not like to mix. So oil is polar, but they don't like to mix with water. And you also saw that the oil did not mix with the methanol, right? So what does that tell you about, whether methanol is polar or non-polar? Okay. Okay, so you know something about the polar or non-polar nature of methanol, right? And you also know the density as it relates to olive oil, right? Or at least oil in this case. All right, so I'm gonna let this sit for 15 minutes. I guess I should put a timer on. Okay, and we'll come back and take a look after 15 minutes. Okay, so it's been 15 minutes total waiting, and this is what it looks like. It may not look like it's changed much but if you look very carefully, you can see there's some orange or red at the bottom, right? So now we're gonna just let this sit overnight until tomorrow, and then see. So it's gonna take some time for it to completely separate. So you can see something is falling to the bottom, right, and it's separating out. And now compare, think about this. Compare this to what it was like before. Think about what was on the top before versus what is on the top now, and think about that in terms of density, right? And look at the volume of these things, and then think about the, what turned into what, or what was changed, and which one's polar, which one's non-polar, things like that. Because these are the only two things that can really tell by looking at it, right? Whether it's polar or non-polar, and whether one is more dense than the other. Okay, so we'll be back with this. Hi, so it's the next day. We remember, this is what I shook yesterday, and now it's been sitting overnight, and this is what it looks like now. So the material that was in there has separated, and it, hold on, it looks something like this, right? So now the red is on the bottom and the yellow is on the top. So think about what that means in terms of the density, and also about whether it's polar or non-polar thing, right? Also look at the difference in the volume of these things too, right? Yeah, so that's what we're looking at. Okay.